I welcome all the students to Pune College of Arts, Science and Commerce, Camp Pune 1. I teach TYBA, Statistics General as subject. I am Dr. M.B. Pathan. In last lecture, we tried to discuss concept of design of experiments, type of experiments, and some technical terms related with design of experiments. Today, we'll try to understand the most important part of design of experiment, that is named as principles of an experimental design. Very important topic. The main purpose of principles of design of experiment is to control an experimental error as far as possible. Yesterday, I defined experimental error. The error which always present in the experiment, which cannot be eliminated 100% from your experiment. Such type of error is also called as allowable variations. But we can try to minimize experimental error as far as possible, but we cannot make it zero. And that's why it is also named as allowable variations from one observation to another observation. According to R.A. Fisher, Ronald A. Fisher, which is also named as father of statistics, this person developed this entire subject under the heading of design of experiments. Firstly, design of experiment was developed by Professor R.A. Fisher to conduct only agricultural experiments. That was the aim at the beginning by Professor R.A. Fisher. But nowadays you can see many statisticians are using design of experiments in various fields. It may be related with production process, it may be related with medicinal experiments, and so on. So according to R.A. Fisher, the experimental error can be controlled by using three basic principles known as principles of the design of experiments. They are replication, randomization, and local control. So if we perform experiment by using these three principles, we are able to manage experimental error. This tree diagram illustrates us about the function of these three principles in design of experiment. On the top, we have replication. Number 2, randomization. Number 3, local control. If I take a help of replication, randomization, it gives me validity of estimation of error. So if you conduct the experiment by randomization principle and replication as a principle, you are able to estimate error in the experiment. There is third principle of design of experiment, local control. This is basically used when experimental material is heterogeneous. So if the material is heterogeneous, you have to apply all these three principles to conduct the experiment. If material is a homogeneous, then these two principles are enough to conduct the experiment. The meaning of homogeneous, the response from each unit of the material is uniform. So there is no variation from the material. We take a help of local control if the material is heterogeneous. That means the response from the experimental unit varies from one to other, from one direction to other direction. So in such cases, we conduct the experiment by using all these three principles. We'll try to discuss these three principles one by one. Number one, replication. The repetition of treatment in the experimental material is known as a replication. I told in last lecture the concept of replication. In the same layout, we repeat a particular treatment for more than one unit, and we record corresponding observation. So this concept, repetition of treatment in the same material, is called as a replication. And I had given one simple example about advantage of replication. I told if the student studying a subject only one time and going for examination, the marks obtained by studying a subject one time, and now if the same student repeat the study of same subject, suppose 3 times, and then he appear in the examination. So I have two experiment. Number one, appearing the examination by studying only once, that means one repetition, and getting the result. Second experiment, same student studying the subject 3 times and going for examination and getting the result. It is quite natural the second result will be far better than first result. So this example says that repetition is nothing but a tool to reduce experimental error. Now, in this example, what is the experimental error? It is the IQ of that student. If students study only once, so understanding of the subject, and if he study the subject 3 times, then what he understand the subject will be different. So by repetition, we are able to minimize error of a chance factor. And that is why replication is very important in the design of experiment. The following are some advantages of repetitions. The replication helps to average out the influence of the chance factor on different experimental units. Thus, the repetition of treatment helps us to get reliable estimates than a single observation. It also helps to obtain more precise estimates of treatment effects. From statistical theory, we know that standard error of the sample mean with our replications, that means with our observations, is given by sigma divided by root r. Yesterday I told about precision. Precision is nothing but reciprocal of variance. So, if I take a reciprocal of this quantity, your precision directly based on the replication. So, this formula says that precision of the experiment is proportional to the square root of the replication. The replication has an important role in increasing the efficiency of the design. Design means experiment. So if you repeat a treatment again and again, the efficiency of design will be increased. The most important purpose of replication is to provide an estimate of the experimental error, without which we cannot test the significance of the difference between any two treatments. If you want to compare two treatments by statistically, we require experimental error. And if you do not have more than one observation, we know that there will be no question of variation. So to get estimate of experimental error, replication is very important. Ultimately, to test the effect of treatment or to compare more than one treatment, experimental error is very important to estimate, and it depends on your replication of the treatment. The adequate number of replications for various treatment in an experiment depends on the knowledge of variability of the material. That means, suppose you are studying 3 medicines to test their effect. So, as an experimenter, I have doubt about the repetition of the medicine. Which medicine should be repeated, how many times to get proper effect. So this answer will be obtained by looking variability of the material. So in general, we take a replications of treatment such that it will provide at least 12 degrees of freedom to the error sum of square. So this is the benchmark to decide repetition of the treatment. For error degree of freedom, the number should be minimum 12. So to get this 12 number, we decide minimum replications of the treatment. Hence, one should not use less than 4 replications for each treatment. So this is a number which is a minimum replications of the treatment, which will provide you minimum 12 degrees of freedom for making a test of the effect of treatments. We have second principle now, that is a randomization. Once we decide particular treatment repeats how many times in the material, the next question in the mind is how to apply these treatments to the material such that every treatment should get equal chance to show their effects. So this doubt, this question which is arise, solved by the principle known as a randomization. The process of assigning various treatments to various experimental units in purely chance manner is considered as a randomization. So what we do, firstly we decide each treatment repeats how many times. Suppose treatment A repeated 3 times, treatment B repeated 7 times, and treatment C repeated 5 times. That means if I want to apply treatment A, B, C, you can say medicines A, B, C. So I require 15 plot, 15 patients, 15 units, because A repeated 3 times, B repeated 7 times, C repeated 5 times. So total repetitions are 15. So I need 15 plot. After that, I want to apply this to the experimental units. Now, if I apply by my choice, then the result will not be perfect. So here what we do, we use the method of purely chance manner. So what I will do, I will make 15 sheets, serially numbered 1 to 15 on a small piece of papers. I put these 15 papers, small sheets, in a bowl, and I will shuffle that bowl, and I will ask any one person to take one sheet outside. Suppose sheet number 8 comes. So I will label sheet number 8 for treatment A. That means now A is applied to the plot number 8. I will put a record. Now this sheet I will put it outside. Then I will repeat the same method again. Take another piece of paper. I will see the number on that. Suppose that number turns to be 3. So I will put my treatment A on plot number 3 and I will make a record. Again I put my hand in the bowl. I take one sheet. Suppose sheet number is 11. So I apply treatment A on 11th plot and I put in the record. So now this way I made the application of treatment which is called as purely randomization. What it does, it helps you to give an equal chance for every treatment to show the effect in the entire material. So the process of assigning various treatments to various experimental units in purely chance manner is considered as a randomization. It provides an equal chance to each treatment to show its effect. The following are main purpose objectives of the randomization. That means why we apply randomization? There are certain objectives. Number one, the statistical test of significance depends on the assumption that the observations xij are independent. That means the yield, the production from every plot should be independent than other plot. This purpose will be served if you apply the treatment by randomization principle. This assumption is valid, true, due to the allocation of treatment to the unit randomly. Next purpose is the randomization helps to control the experimental error as far as possible. Third purpose is the purpose of randomization is to assure, gives the guarantee that the source of variation operate randomly in the experimental material. In turn, gives you average effect altogether as a zero. So when you apply treatment random basis, on an average, effect of experimental error gets zero. And that is the main advantage of randomization. Now, third principle of design of experiment is local control. The division of heterogeneous experimental material into homogeneous subgroups, commonly called as a block, is considered as local control. I told at the beginning only, if the material is heterogeneous, then we use local control. If the material is homogeneous, response is uniform, then there is no use of local control. It can be done by taking help of uniformity trial, which we have discussed in last lecture. Heterogeneity of the material increases experimental error. If the material is heterogeneous, there will be large variation from one element to another element. And if the material is homogeneous, there will be small variation. So heterogeneity is one of the main factors which responds for experimental error. And our basic purpose in design of experiment is to minimize experimental error as far as possible. So if the material is heterogeneous, we try to apply local control by which we can able to reduce experimental error. How we can do? It is done by conducting uniformity trial. We divide the material in different small plots. Suppose I divide my experimental material in capital N plots. Then for all these N plot, I apply a single treatment. That means from treatment side, there is no variation because only one treatment is applied. What the variation you will get from the observations, it is totally due to material. So we make a record of this experiment which is called uniformity trial. This we have discussed in last lecture. By using this, we plot fertility counter map. And then by using fertility counter map, we collect those plots having almost similar response as one block. And then we take another collection of the plots which are having almost similar response. So by this way, we try to divide heterogeneous material to homogeneous subgroups known as blocks. How we do? If the fertility of the material increases in one direction, then we divide the material perpendicular to this direction. For example, if fertility increases horizontally, then we make a block vertically. If fertility increases vertically, then we make blocks horizontally, perpendicular to the direction of fertility. Fertility is nothing but response of the material. Is known as randomized block design. If we divide by perpendicular direction, then corresponding design is called as a randomized block design. If the fertility of the material changes in both directions, if change in one direction, the corresponding design is randomized block design, RBD. Sometimes what happens, response of the material changes varies in both directions, vertical as well as horizontal. In this case, we use Latin square design. So if fertility, be remember, if fertility changes in both direction, the design is named as Latin square design. If the fertility changes in one direction, the design is called as randomized block design. And if the material is homogeneous, then design which we use is completely randomized design. You can see how it works. Therefore, local control helps to increase the efficiency of the design, because by using local control, we reduce the variability by dividing material into homogeneous subgroups. Ultimately, we reduce experimental error. This is a diagram which gives you idea how to make subgroups. If fertility goes by this direction, then you make a subgroup by this direction. If fertility increases vertically, then you make blocks in horizontal direction. So blocks and fertility, they are perpendicular each other. That is to be remembered. Now we have last topic, then we'll stop today. Size of the plot. That is, what should be size of unit to divide the material. The smallest part of the material under study on which we apply the treatment is considered as a plot or unit. The size of the plot depends on the total experimental area. If it is agriculture experiment, size of the plot may be in the acres. If your size experiment is a medicinal experiment, then your experimental unit is a patient. So group of patients will be your units. The number of treatments under study. That means size of the plot decided by looking total area of the experiment, how many treatments under study, how many replications you have to perform, and crop variability under study. So many factors you have to take under consideration to decide size of the plot. Number one, you take a factor under consideration area of the material, how many treatments are under study, how many replications you are going to do, and so on. If the total area of the material remains fixed, then an increase in the size of the plot will result in a decrease in the number of plots. While deciding the number of plots, it should also be kept in mind that increase in number of plots increase non-experimental error. This error word should be there. This is according to Fairfold-Smith's variance law. One statistician, Fairfield, has given the relation between size of plot and variation between the units and material. So Vx equal VL divided by x to the power b, where Vx is the variance of the yield per unit area from plots of size x unit. That means we fix size of the plot and then we conduct the experiment and we find the variance. V1 is the variance among the plots of size unity. That means take a uniform size and conduct the experiment and get a variance. B is the regression coefficient between soil. Now, I told before, design of experiment basically developed to study agriculture experiment. That's why here we write soil. Nowadays, it is applicable to each and every field where variations can be analyzed. Now, soil characteristics. Again, adjacent units. The limiting value of these, you can see, gives the answer of your size of the plot by solving this relation. Today we'll stop at this stage, that is the end of your first chapter under the heading of design of experiment. Next lecture we'll try to see analysis of variance for the design which is based on two principles, replications and randomization. That means we conduct the experiment by assuming the material under study is homogeneous.